When we finish this Chapter 8 review page, you'll find that you've got a one-page summary that pretty much describes the whole chapter and will serve as a pretty good review sheet for you. We begin by simplifying this first radical by taking the 40 and breaking it down into 4 times 10. And the 4 can further break down into a pair of 2's, but the 10 will break down into a 2 times 5, neither of which will come outside the radical. When the 2 does come outside of the radical, it will multiply by the 6 that is already there, giving you 12. And then you're going to have the 2 times 5, which is 10, left over on the inside of the radical. Now we take the x to the third, and because there's an understood index of 2 being a square root there, we take our 3 and divide it by 2 to get 1 remainder 1, and our other y squared 2, divide that by 2 to get 1. That tells us we're going to have 1x and 1y coming outside of the radical, and we're going to have 1 extra x left over inside. And I'm going to assume that this problem is going to have a statement saying assume that all variables represent positive values so that we don't have to use absolute values. But if that statement were not there, the absolute values would go around the x and the y. When it comes to addition, you can only add radicals together that have a common radicand, and both the first and the second have a root 3 within them. So those can be combined together to give you 11 root 3, you keep the radicand the same, minus 7 root 2. And that cannot be further simplified because there is a different number inside each radical. When it comes to multiplying, as we see on this next problem, we multiply the coefficients 5 and 2 out front first, and then we multiply the radicands 3 and 6 together second. That is going to give us a 10 root 18. And the 18 can be broken down into 9 times 2, and that 9, I'm going to do a little sideways factor tree here, gives us a pair of 3's. That 3 that comes out will multiply with the 10, giving you 30, and you have that leftover 2 which stays inside. This next problem has addition and subtraction within the parentheses, and we recognize it as a FOIL problem. The first term of FOIL has you multiplying the 3 times 2 to create the 6. The outer term, that's the 3 and the minus 4 root 3. The 3 only multiplies with the 4. It cannot multiply with the number inside the radical. So that gives us a minus 12 root 3. Then we have inside 2 root 3 times 2, which gives us 4 root 3. Minus, and that's because of the positive times the negative, 2 times 4 on the outside, which is 8, 3 times 3, which is 9 on the inside. That becomes 8 times 3, and that becomes a minus 24 at the end. That will combine with the minus 6 at the front, giving you negative 18. And these middle two terms both have the same radicand and can be added together to give you minus 8 root 3. Be careful on this next problem because you cannot shower that square symbol in across the plus sign. Instead, we need to rewrite this as 2 root 3 plus 5 root 2 times again 2 root 3 plus 5 root 2. And I recommend you pause this video, do this out, and then check yourself afterward. But here we go for those of you who aren't pausing, or for those of you who have turned this back on to check. Here we go. First term of FOIL, 4 root 9, comes from the 2 root 3 times 2 root 3. The outer terms of FOIL, the 2 root 3 times 5 root 2, gives us plus 10 root 6. On the interior, same thing, plus 10 root 6 again. And the L part of FOIL will be positive 5 times positive 5, making positive 25 root 4, which turns into 25 times 2, which turns into 50. And out in front, that 4 root 9 becomes 4 times 3, which turns into 12. So, combining the first and the last terms together, we have 62. And putting the two 10 root 6's together in the center, we have plus 20 root 6. Do not factor a 2 out of this. This answer stands as is. It is considered more simplified as it is. Factoring is not necessarily simplifying. Okay, now we turn our attention to division. And in this first problem, before we rationalize and multiply by root 3 over root 3, we notice that we have two inside numbers that can be canceled. If we think of this as a single square root, then you can see that 21 over 3 can be reduced and give you root 7.